All right, raise your hand if you miss high school math class.
Bueller. Bueller.
So today we are going back to high school geometry class, and we are talking about making non-90 degree miter joints. I made a video a while back on clamping weird angle joints, but I was focusing on things like furniture legs where the geometry was open and flexible. So for this one, I'm going to talk about long miters and making enclosed cases with non-90 degree joints. Now, I won't lie, it's going to get a little mathy here for a couple minutes, but I'll try and be like the cool high school teacher you had. I wish I had like a leather jacket.
They give all the teachers students. I'm Jonathan Turner. You can call me Mister.
So let's first start with what I'm making. This is the top to a little end table that I make, and I wanted to make something that wasn't just a box on legs. So I went with this trapezoid shape. So when you make a box with 90 degree corners all the way around, you either have all four sides the same length or two parallel sides equal and then the other two parallel sides equal. So it makes it very easy to get everything to line up properly. But with a trapezoid, you have two sides that are equal length, and then you have the two other sides that are different lengths, but they are completely dependent on the length of the opposite side, as well as the angles at the corners. Now, I'm a big proponent of not being too crazy about exact dimensions and angles, and I kind of like to just build things that look good to my eye. But in the case of boxes, you have to be really exact to get everything to line up and come together nicely. So the first step to all of this is figuring out the dimensions and angles, obviously. And this is the math part, so if you don't care about this stuff or you're not interested, skip ahead to
547.
That's where all the sawing and building starts. Anyways, let's go to the whiteboard so I can draw all this stuff out and so I can feel like I'm a real high school teacher. So I'll start by drawing my trapezoid and filling in a couple of the dimensions that I already know based on how I want the box to look. I know I want my top two corners to be 80 degrees, which means my bottom two corners will be 100 degrees because the angles on each side have to add up to 180 degrees. At this point, I can decide how wide and tall I want my box to be. So just for the sake of the example, let's say I want the bottom of the box to be 12 inches wide, and I want the total height to be 6 inches. This leaves us with two dimensions that we need to figure out based on the information that we have so far. And this is where it gets good, so stay with me. What I do is cut out these outer triangles to make them a separate shape, then fill in all the angles and the one dimension that I know. I then can use trigonometry to figure out the other two sides of the triangle. That's right. Trigonometry. Don't close the window. It's not that bad. Trigonometry is just the math that deals with the relationships between the angles and the sides of a triangle, and it uses functions like sine, cosine, and tangent. And all you really need to know are two things. One, sine, cosine, and tangent are just buttons on your calculator, so that part's easy. And then you need to remember this phrase, SOHCAHTOA, where we have sine, cosine, and tangent, and then we have O, A, and H, which stand for opposite, adjacent, and hypotenuse. So I think I'm just gonna solve for X and Y here, and hopefully that'll illustrate how all this trigonometry stuff works. Let's start with finding our X side, and we're gonna use the bottom angle of 10 degrees to figure this out. So labeling our triangle with the part names, we have the adjacent side, the opposite side, and the hypotenuse, which is just the longest side of the triangle. So to find X, we'll use whatever function uses the opposite side and the adjacent side relative to the angle we're using. And in this case, it's tangent. And from here, it's very easy to set up the equation to find x. It's just the tangent of our angle equals the opposite side divided by the adjacent side. From there, we just plug the tangent of 10 into our calculator. And then it's just some simple algebra to solve for x, and we come up with x equaling 1.058, which we then of course can convert to 30 seconds or 16ths or whatever to get a pretty accurate number. We can now do the same exact thing for y, this time using cosine, because we'll have adjacent over our hypotenuse, which is y. So now when we come back to our full trapezoid shape, we now know the length of the sides, and then we can add our value for x plus the length of the bottom side plus the length of x one more time to get our entire full top length. Okay, take a deep breath. The math is done. If you skip to this part, I totally get it. Just don't send me an email asking me to solve for x or anything. But now we can get to the fun part of actually cutting all of our dimensions and angles that we just figured out. And the good part about this is that we only have to set our saw blade angle once, and we can do all the cuts. So since a table saw blade can only tilt to 45 degrees, we're gonna tilt it to 50 degrees since that's half of our 100-degree bottom corner. So with that, we can cut the miters on both sides of the bottom panel as well as the bottom edge on both the side panels. In order to cut the upper miters, since they're greater than 45 degrees, we're gonna have to run the workpiece vertically through the saw. But we don't have to change the saw blade angle because it is the complementary angle to our bottom miters. Now, in order to do this cut safely, we need to make some sort of jig, and if you've watched my previous videos, you know I'm a fan of quickly and somewhat poorly made jigs. You know what I always say? You can't look like a jerk if the jig works. But the main reason for the jig is to hold the workpiece as we push it through the saw blade, because once you make the full cut, that workpiece is gonna wanna fall into the blade, and that can be bad. Now you can get as fancy as you want with something like this, but all I do is I take my router fence and I just clamp my piece to that. There you go. After that, it's pretty much like any other box. I'll add some dominoes for alignment and some strength, glue it up using every clamp I own, have a mild freak out halfway through, question my place in the universe, but it usually works out in the end. So, man, I hope this one wasn't too boring. As I'm filming this, I feel like it might be, but I always liked math in school, so there you go. And of course, thank you for watching. This is officially the last video that I will be shooting in this shop, as I'm moving everything out tomorrow, or I guess today, if I get this uploaded in time. So that's pretty exciting. I'm also starting to post short, quick videos, hopefully a couple times a week on my Patreon. And that's just a way to kind of post some updates or things that I want to talk about that don't warrant a full YouTube video. So if you're interested in stuff like that, check it out. I was also hoping to have plans ready for this piece, for this video, but that didn't happen in time. But I'm still hoping to have those done somewhat soon, and I'll let everyone know about that once they're ready. Of course, links to everything I talked about are in the description. All right, that's all I have. Thanks again for watching. So until next time, if you think figuring out all these angles is a bunch of trickery, just relive your high school days and use some trigonometry.